All right, so this course is called Getting Started with the ALiEn2 and ALiEn2 Expert Plunger Lift Controllers. So just to go over the agenda, we have some information about our simulator, basic navigation, the plunger cycle. We'll go over the different models, what connections they have, how you'd wire them, the optimization portion of the cycle, and then we'll go through the install menu, settings, and history. And then finally, we'll show you how you can get more support resources to get up and running with the controller. So this is the simulator. It's available to download for free off of our support website at support.etcorp.ca. If you go under products and click ALiEn, all of the downloads for our tools and documentation are available there. So this is what the simulator looks like. You can see this is the controller faceplate. You've also got all of the inputs that you can stimulate or work with. And you've got a number of menu items, and we'll go over some of those in a minute. Things like manuals and instruction labels and other help is available in there. So the main area is on here. This screen, the state or menu portion of the screen, this is the current controller state, as well as when you're navigating in the menus, it'll show you where you are in the menus right here. The status window is a separate window, and it shows you things like valve statuses, battery voltage, pressure values, and this just continually scrolls, and you don't really get to change that except for enabling or disabling different devices. Then these keys here are relatively important. We have hotkeys to open and close the well. So open starts the rise portion of the cycle, and close puts it back to a closed cycle where the plunger will fall. We've also got settings and history, which are meant for operators primarily, and then in the install menus where we set everything up. You'll notice over top of the number keys, we've embedded navigation keys. So this allows you to scroll up and down in the menus. So up is to scroll up, down is to scroll down. You can go into the menu by pressing select or the right arrow. You can go out of a menu by pushing left or cancel. So you've got a number of different functions overlaid on the same buttons here. And as we walk through the simulator, it'll become apparent how to use them. It becomes quite intuitive. All right, so in the simulator, you can click instruction label under help, and this will actually bring up the instruction label that's installed on the inside of the controller box. So it's always there for reference, both in the simulator and the controller. It shows you the layout of what's available in the install menu. It also shows you from the main screen, if you navigate up and down, you can go through current state information, what the cycle type is or when it started, and the current date and time. And you can also change the state. The status screens, 1 second here, put you on mute. The status screens, it'll show you what will roll through there. So battery, solar, the temperature, valve statuses, and device statuses. And then it gives you an overview of the keys. So if you ever need a reminder, you can open up this instruction label. So this is the plunger cycle. So as you can see, we start with rise. And then rise is opening the well. The plunger comes from the bottom of the well to the top. Once the plunger's arrived, we move into afterflow. So this is the flow portion of the cycle, or the sales, that happens once the plunger has come to surface. We remove the fluid. When the afterflow time expires, we close the well, and then the plunger begins to fall. The closed portion of the cycle also includes any kind of pressure buildup time, and we'll get to that later in the pressure optimization portions of the cycle. But as you can see, this cycle just continues indefinitely. Rise, afterflow, close, again and again and again. Now, there is a portion of the cycle where we can go to stop. And so if a fault condition happens, we can stop the controller and wait for operator intervention. So the most common way this happens is a fast plunger arrival. So we have two different types of fast plunger arrivals. There's a dangerous trip, which is an extremely fast plunger arrival. So 640 meters per minute or 2100 feet per minute by default, and you can change this. But if a plunger arrives faster than this, it will immediately shut in the well on a single trip. There's also the ability to have a lower fast trip set, so 315 meters per minute or 1,034 feet per minute. The well will only shut in on a certain number of consecutive fast trips. And we can set that in the alarms menu, and I'll show you that when we go over the menus. As well as if you're getting non-arrivals, so if the rise time expires and the plunger has not arrived, after that's happened a set number of times, we can send ourselves into stopped if this is enabled. And by default, this is disabled. And once again, the rise time is set based on this 150 meters per minute or 492 feet per minute. As well, we can shut in based on a low battery to make sure that the valves are left in a no-in state. So a low battery is less than 5.5 volts, and we have to read that 3 consecutive times in order to indicate that a low battery has happened. And then as well, you can push it into the stop state yourself. The close and open buttons that are available on the keypad, like I said, close will start the close portion of the cycle, open will open the well and start the rise portion. But if you hold either of these buttons for 3 seconds continuously, it will do a hold open or hold closed, forcing the controller to be stopped. Here's an overview of the different models. So we actually have 3 different models currently. So ALiEn2 Expert is the most feature rich. It has the most pressure inputs. It has an additional communications port, so it can act as a Modbus master when interacting with a velocity sensor. It has time optimization or velocity optimization built in, as well as optimization on the pressure inputs. The ALiEn2 is a slightly stripped down version of the ALiEn2 Expert, so you lose some of the optimizations. You have a slightly smaller battery. You don't have that second COM port. Both of these models are hazardous locations approved as Class 1 Zone 0 or Class 1 Div 1. We do have a really low entry model controller. This one doesn't have as wide a temperature range. It doesn't have as much standby, so it's got a standard temperature LCD screen instead of our wide temperature range VFD screen. It only supports a single valve and it has some basic pressure inputs as well. And in both cases, you can upgrade the optimization, the time-based optimization or the adaptive seeking velocity optimization. We can enable that as a feature. It doesn't require any additional inputs. It just uses the plunger arrival sensor. But do note this is uncertified. There is no certification currently on the ALiEn2 Lite. All right, so if we look at the connections that can be made, so our standard controllers come with a plunger arrival sensor input and a line pressure input. And you can see where these are connected. The line pressure is connected on the other side of the valve so that we can monitor for a high line pressure condition. And then the plunger arrival sensor is mounted at the surface on the lubricator to detect when the plunger comes to surface. On our expert level model though, we have additional input features. So casing pressure, which is on the casing, so you can measure the casing build. We've also got a tubing pressure input, so that you can measure the pressure in the tubing or just on the other side of the valve, so that you can compare now casing, line, and tubing. We also have the ability to have a differential, which is the change in pressure over an orifice plate, which is used to calculate flow. So if we actually look at the back of the controller, this is the certification label and input connection labeling. You've got a battery connection. You have to use an approved battery. So it's a specific voltage and current rating with protective circuitry, so it's safe. There's also a solar input. We have a approved 1.1 watt solar panel that can charge the battery and provide enough current to run the controller. One thing to note though is you do want to make sure that the battery is plugged in before the solar panel, or you can get an odd case where, you know, if you don't have enough light, the controller starts to run off the solar panel alone and gets into an unknown state. So it's always best to plug in the battery first. The valve connections, these are all keyed connections. You can't see them on the label here, but they're keyed plugs that you can plug in. Every controller comes with a sales valve. This is the main production valve where you can close in the well or open to flow or sell gas. And then we've got 2 more valves on the expert level model, a valve B, which you can use to float a tank. You can use it for gas injection. You can use it as a flow tee. There's a number of different options, and we'll go through those later. And there's also an independent auto catch. So, you know, to save your catcher, you can engage the auto catch on arrival as opposed to turning it on when the well's turned on. So that allows you to set that. And then as well, you can hold the plunger at surface after the well has been closed to let the well settle down before dropping the plunger. So that's an independent auto catch feature that's enabled on the ALiEn2 Expert. The other inputs that are available, COM1 is on all models. This is the port that you're going to use to connect your SCADA system. The ALiEn2 and ALiEn2 Expert act as a Modbus slave. So we use standard Modbus that you enable in the software, and we'll show you that in the settings in a minute. You can also use this port to upgrade the firmware. So all of our products have upgradable firmware. You can plug in a PC, use our Vision device management software, and you can load the latest software here when there's a new version. The plunger arrival sensor, talked again about this being a common input. It's enabled by default on all our plunger controllers because most of our customers want to use a plunger arrival sensor. We support both a 2 and a 3 wire. So if you have a 2-wire sensor that's battery powered, you can just connect to SIG and COM, and when it closes, it'll signal the arrival of the plunger. We actually would prefer that everybody uses a 3-wire. In the case of a 3-wire sensor, we deliver power, and so you don't have a battery that's going to die, and you've got the ability to modulate when that power is on and off. And so, of course, we recommend the Cyclops, which is the market-leading plunger arrival sensor and works best with our controller. These are the pressure inputs. You'll notice there's only 2 pressure inputs. On the base, there's only a single one, but on the Expert model, there is 2. But we've multiplexed some of these functions on top of each other. So casing pressure and differential pressure are combined, and line pressure and tubing pressure are combined. So once again, you can use 2 or 3 wire, so a 2-wire Murphy switch, but you can only know when the pressure has tripped. You don't know what the pressure value is. If you use a 3-wire pressure transducer, and we provide these from a partner, GEMS, and these are intrinsically safe or class 1 zone 0, class 1 div 1 pressure transmitters that will allow you to actually get a value into the controller, and then you can act on it. So you can see what the casing pressure is, or you can do casing minus line pressure. You can look at the performance of casing over time to shut it. There's a number of different features, and we'll highlight that in a later slide. Do note that if you do need more than 2, if you need 3 inputs, so in the case of load factor, you need casing pressure, line pressure, and tubing pressure, we do sell a pressure splitter that you can plug into this input, and we can use a spare valve output to switch between tubing pressure and line pressure to give you the 3 pressure transmitters. And then this COM2, this is only available on the Expert. This is a Modbus master, and it interacts with our Sasquatch plunger velocity sensor so that we can read surface velocity values out of the Sasquatch plunger velocity sensor. And do note, as I expressed before, these 2 inputs are only available on the Expert model. So if you do want to use the Sasquatch or you do want to use pressure optimization, you need the Expert level model. All right, so let's talk about the plunger cycle a bit more. When we go from close to rise, this is when we're checking all of the pressure conditions that are required to open the well. So the conditions to open, this is dependent on the devices you turn on, but we can look for a low line pressure. So we prevent the well from opening on a high line pressure. So we're looking for the low pressure, line pressure to be low enough. We're also looking for a high casing pressure or a high casing minus line pressure to say that it's good enough pressure to flow the well. We've also incorporated high tubing pressure, so you can open on high tubing, and you can also open on low load factor. So we can actually calculate the load factor, which uses the weight or the load of the fluid and the lifting ability to determine if the pressure at the bottom of the well can lift the fluid that's stored in the column. Now, also from going from afterflow to close, so what we always do is we run a minimum afterflow time before we start checking the pressure sensors. Once the minimum afterflow time is complete, we start relying on the pressure sensors to determine when to close the well. So these are the conditions that allow you to close the well and move it out of afterflow. So a high line pressure, a low absolute casing pressure, a low casing pressure rate of drop. We can actually look at how fast the casing pressure is dropping and determine it's slowed, then we want to close it. A low differential pressure, so this is equivalent to a low flow rate. So these are really the same thing. In a low differential pressure, we're just using the inches of water column or the inches of mercury to determine that the flow rate is dropped and close it. In a low flow rate, we're actually using the differential pressure along with a static line pressure and orifice plate settings so that we've got a flow rate that we can close in on. And I've got a whole other course based on pressure optimization. So I'd refer you to that course. There is a recording on our website, and we do give that on occasion if you want to learn more about pressure and time optimization. All right, so the install menu. So as you saw in the simulator, there's an install button here. So if you press install, it comes into the menu. The arrow indicates where you are in the menu, and you can scroll up and down. So the first item is date and time. And this is something you want to set up always at the beginning of any kind of new install. The date and time will be set to 0. We don't have a battery backup. So you have to set the date, you can set the time, and then whether you want to use daylight savings time or not. Do be cautious though. If you've ever removed the battery, whether it's to replace the battery or you unplug the battery to service it, you are going to need to reset the time because once again, there is no battery backup once you unplug the main battery, and so you'll have to reset that time. The next item is system. So system gives you a number of settings and information about the overall system. These aren't specific to running the plunger well, but it's things like the display brightness. So if you want to increase the display brightness, we keep it relatively low to save power. If you want to change the auto off time, so this is a screen timeout. So after you haven't touched a key for 30 seconds, it will turn off the screen to save power. If you'd like that to be longer, you can go ahead and change that or shorter. Just keep in mind, if you make this really long or infinite, it won't go quite infinite, but if you make it a really long time, you will use up quite a bit more battery because the display is one of the key drivers of the power consumption. You can set the units. So by default, we have imperial units, but you can set metric so that you get KPI instead of PSI. You get meters instead of miles or feet, and you can change that. There's the serial number, the software and hardware versions. These just typically let you know what generation of product you have, whether you need to upgrade the software, and helps in any kind of troubleshooting. As well, there's an auto logout timer. So we'll get into security in a minute, but what it will do is if you've left it on a screen inside the menus, after 10 minutes, it will go back to the main screen. If you do have security enabled, it will log out the user. And then at the end of this install is where we find an error log. And we're not going to talk about that too much. It's available in the menu and in our support site, but there will be log entries that show up here. If you ever get a controller restarting or going back to close, going here and finding this error log will help to troubleshoot the problems. So in the security menu, which is the next item, the installer that's putting it in can turn on security to have an ID that's required for both the installer and the user. And the installer and user have different abilities. So the installer can turn on more settings, can change more of the restrictive settings. The operator, we can lock out some of the operator settings. It is disabled by default. When you turn it on, you'll see there's both an operator and an installer ID that are set to all zeros. Once you turn it on, you'll want to change that, obviously, because there's no point in leaving it at the default. But if you ever do come to a controller that has security turned on, you could try that in order to get in. If you ever do get locked out of a controller that you own, you can contact ETC support and provide your serial number. We can provide a super user code per serial number, but it is best if you set your operator and installer IDs to something you're going to know and to be able to go in and set them yourself. The well setup menu, this is a common menu that you set up all of the times and velocities. So we don't have any like pressure values and stuff in here or other valves. Those are in a separate menu. But if you want to use time or velocity, you can pick and choose. You set up the well depth, and then any of the times, like a close time or a rise time, you can choose to set up the time or the velocity, and the opposite will be calculated. So once again, velocity, time, and depth are all related. So these are some of the settings you'll find. So well depth, you set how much the well depth is so that when you set your velocities, the times will be calculated automatically. The well depth is also used for tracking plunger stats. So how much kilometers or miles your plunger has traveled, we'll use this well depth in that calculation. Danger time or velocity, once again, this was the incredibly fast plunger arrival that we want to shut in the well immediately. A fast trip time or velocity is what we use to determine what is considered a fast plunger, and then we look at how many consecutive ones arrive before taking action. Rise time, this is the time that we're allowing for the plunger to go from the bottom of the well to the top before timing out. If it does time out, we consider it a non-arrival. Close time, once again, this is the time that we're allowing the plunger to fall and any kind of pressure build. So depending on what kind of optimization you're using, if you want to set a close time that's greater than the fall time, you can do that. Then there's min and max close time. What this does is this limits the close time setting. So if you want to make sure that the close can never go below a certain value or above a certain value, you can set that here. One of the common complaints an operator might have is I can't set the close time to what I want. Make sure that the installer has set the appropriate min-max close time window. The non-arrival close time, this is usually 2 times close, but you can set it to whatever you'd like. If you have a non-arrival event, it will apply this non-arrival close to give extra shut-in time to build pressure to rise the plunger. So similar to the close time, we do have a min-max afterflow time and an afterflow time. It sets the parameters. This is used not only for controlling the values the operator can put in, but also the optimization in both the close and afterflow time cases. So it will bound the adjustments that can be made to the close time or afterflow time. And then once again, this is the current afterflow time. And this is the time that will run after the plunger arrives and before we close the well again. So inputs, so if we've plugged in physical inputs, we need to come into this menu to configure them. Everything is disabled by default, so we don't turn on power, we don't look at those inputs at all until you actually enable them. So the different types of inputs, so PAS or plunger arrival sensor, it is enabled by default, but you can enable it or disable it here. If you just want to intermit the well, turn off the plunger arrival sensor. It's also got a setting of when to apply power. What we do on our controllers in order to get the lowest power consumption is we only apply the power during the rise portion of the cycle. So only when we're expecting the plunger to arrive. And you can make it always powered. Some sensors out there don't like to have their power turned off, so you can leave it on all the time, or you can add a delay so that when they do get powered up, you don't respond to some of the glitches you'll see with some of our competitor sensors. If you use the Cyclops, you don't need to do either of these things. And then as well, there are some sensors on the market that work backwards. So instead of being normally open, they might be normally closed. So when a plunger arrival happens, the switch opens instead of closing. And once again, normally open is the default. Most plunger arrival sensors will close on arrival. You've also got all of your pressure inputs here: line pressure, casing pressure, tubing, differential, and flow. All of them are disabled by default. You can set them to a switch or sensor or virtual. So once again, switch is just on or off. You use the 2-wire connections on the back. Sensor, this is a powered transducer where we actually read an analog value and we convert it to a digital value on the screen. And then virtual means it's just a Modbus value and it gets written in from another system. For a switch, you can set the polarity once you've enabled the switch. If you do set it as a sensor, you can set the sensor range. So if it's a 500 PSI or 1000 PSI, it will scale the analog value appropriately. We've also got the option to enable device logging or input logging. So if you do want to save the values, so we'll use the values of line, casing, tubing, differential to do control, and we'll save the point in time that causes a change in the control algorithm. But if you want to keep, line pressure every minute or every second, you can enable that in device logs, and then it can be read out with Modbus. The outputs menu. So the outputs menu is where we can set up any kind of valve valves, digital outputs. It shows the valve status and configuration. So valve B, here we can set the different modes. There's a bunch of different ones. They're all in the menu or in the manual, sorry. Tank is dumping to tank. Line, it's connected to the sales line. You can have it either opened or closed during afterflow. Purge and GAPL are for injecting gas at the end of close. GAPL can be interacting also with pressure sensors. Flow control, it's the valve B is open during rise. And then once the plunger arrives, it gets closed so that you're flowing underneath the plunger. So it's just different valve positioning. The auto catch, once again, this is the independent auto catch. So you can engage it on rise so that you've turned on the auto catch and it's inserted while the plunger is coming to surface, or you can wait for the plunger to come up and then engage it to try and save your auto catch a little bit. You can also specify that hold time to hold the plunger at surface before going to close. There's also LPTP select in here. So we can take either valve B or auto catch and we can make it LPTP select. And what that does is that's the switching for the pressure splitter. So if you're not using one of these other valves, you can connect a pressure splitter and use it as a control signal to switch between, say, tubing pressure and line pressure. And then other outputs, we have the ability to have a discrete output. What we actually do is we take pressure inputs that you're not using and we can use the pressure or the power pin as an output. So normally that power gets delivered to a pressure sensor to enable it and so that we can read it. But what we can do is take these unused power pins and we can signal an alarm, or we can use it to mimic a valve. So if you want to use an electric valve, you would connect an optically isolated relay to the power pin of an unused pressure input, and then you would turn it on to mimic valve. We have application notes about this on our support site for electric valves, and it goes through how to do this. The alarms menu, this allows you to configure the counts to send the controller into alarm. And then we've also got some screens here that allow you to decide what to do in a failure case. So a pre-non-arrival count. So instead of going directly to non-arrival and having more close time, you can actually count a number of missed arrivals before you start to add more close time. This non-arrival, once you have so many of these pre-non-arrivals, so if you set this to 3, for example, and you have 3 missed arrivals, then you go into non-arrival and you run the additional non-arrival close time. So the non-arrival count as well is you can run that extra non-arrival close time up to 99 more times if you want before shutting in the well. This is typically disabled, but you can make this 1, 2, 3, anything you would like. Fast trip count. How many consecutive fast trip events are you willing to take before you shut in the well? It's the same as the non-arrival count and the pre-non-arrival count. You have to have a set number of consecutive events before taking actions. So in all of these cases, like the non-arrival count and the fast trip count, once we hit those, we're stopping the controller. And then you can determine when you stop the controller for these things, or on a low battery, or on a danger arrival, what action to take. So you can either fail open or fail closed. So on a non-arrival, if you'd rather fail open than fail closed, you can do that. We found that a number of customers were complaining that an operator would come up to the plunger controller after it had been shut in for a long period of time and they just hit open, and there's so much pressure build, they end up damaging the spring or the plunger and causing a service call. So if you'd prefer to fail open on these things, you can do that, and you can set it for each one of these things individually. The optimize menu. So once you've got your pressure sensors plugged in, once you've got them configured with their range, you can actually use them to enable optimization. And so you get to choose in this optimize menu whether you want to optimize on time and velocity or on pressure. And so close afterflow or close then afterflow, these are all modes that use the plunger arrival time or the plunger arrival velocity to optimize. So sometimes you've heard close referred to as oil optimization. Afterflow is sometimes gas optimization. Close and afterflow is oil, then gas. And so in this case, close and afterflow, We try to minimize close first, then maximize afterflow in order to dewater the well and then maximize our sales. The pressure and flow options, if you turn that on, then you can use the pressure sensors or the flow sensors to optimize the well instead of these times. So adaptive seeking velocity optimization, this is what we use for this close afterflow or close then afterflow. We make proportional adjustments to the close or afterflow time. So what we do is we look at the arrival and we see how fast it is based on when we expected it to arrive. So how fast or how slow it is compared to when we expected it. And we make that proportional adjustment using the current close or afterflow time. So a well that's flowing for a large amount of time will have a larger adjustment, and a well that's only flowing for a small amount of time will have a small adjustment. The same applies to the close. We do also allow you to apply a scale factor. So I think this is set to 10% by default, but you can make the algorithm more aggressive or less aggressive depending on what you want for performance. So if you wanted to get there and make big adjustments and get there quicker, but have a little bit of overshoot, you can make it more aggressive. If you want it to be slow and steady, you can lower that scale factor. And there is a scale factor independently for both close and for afterflow. For pressure and flow optimization, what you have to do is enable the different states where you want to use a specific device. So an example might be, I want to use open casing pressure. So then you can set the criteria to open the well based on casing pressure. So you get to choose which states and which devices to use for pressure optimizations. If you don't turn on any of them, what they'll do is they'll just monitor those pressures but not act on them. And each time that you set this up for a given sensor in a given state, you set the stable time. So how long does it have to go over a trip or a reset before you consider it tripped or reset? So you can say, I set a stable time of a minute, so you can ignore spikes in a pressure value. And then of course you have a trip and a reset condition. And you have to think about trips and resets about, trip would throw it out of a cycle or hold it from going into another cycle. Reset allows it to continue in that cycle or allows it to continue to the next cycle. So for example, if you're going to open on casing pressure, if it's tripped, it will hold it enclosed until the pressure value has reset, and then it will go to rise. Conversely, if you're in the afterflow portion of the cycle and you're flowing and you're measuring, say, flow, when the flow trips, it will kick you out of afterflow and go to close. The Modbus menu. This is allows you to enable a Modbus slave on COM1 to connect to SCADA. So once again, we disable this by default to save power. If you're going to want to connect it to a SCADA system, you go and turn on COM1, and then you set the settings. These are all COM port settings, and they have to match the Modbus master. So if you're talking to a radio or if you're talking to a remote master, this device has to have a station address so it can be uniquely identified. But then you set up protocol, baud rate, data bits, parity, and stop bits to mimic the other transmitter. And they have to just match. RTU and ASCII, this is a Modbus specific thing that allows you to send things in binary or in character format. Typically, you're going to find that this is RTU, and then baud rate, data bits, parity, and stop bits. The default is 9600, 8, N for none, and then 1 stop bit. One other setting in here to pay attention to is the time format. This enables the times that are in the controller to be delivered to the SCADA system in the format that it needs. So there's 2 different types of formats. There's the elapsed seconds since January 1st, 2000. So this is just a flat number of seconds, or it's in 3 registers representing hours, minutes, and seconds. All right, so that's the install menu. Now let's go back to the couple of hotkeys that you have here that operators will use. So settings, once you've installed everything and set it up, this is where all the common settings are put. So your close time, your non-arrival close time, you can see that we don't have the mins and maxes in here. That's done in the install menu. So we've reduced the number of settings here to make it simpler for operators, but it is a bit more constraining. So rise time, fast trip time, afterflow time. There are other things that will appear here as you enable those features. So if you turn on adaptive seeking velocity optimization, the target rise time will show up. If you turn on casing pressure and you're using it for optimization, you'll get the open casing pressure set points. So, do pay attention here as you turn on more things. If there's something that's not in here, it's probably not enabled. In the history, so if you click the history button here, click it in the simulator or press it on the controller, you get a number of different logs. So for cycle logs, there's two different types of cycle logs. There's a simplified rise time log. This just shows you the last 25 rise times. A lot of operators like to come up and just see what their rise times were without any other data in there to make it confusing. If you look at the cycle log, this is the same last 25 cycles. It gives you the date and time when that cycle started, and it gives you more information. It still gives you the rise time, but it also gives you afterflow time, the vent time, close time, afterflow, casing pressure. So this is if you're using casing pressure to shut in the well, it will tell you what casing pressure it had when it shut in. There's two more total logs. So there's both a daily total and an overall total. So daily gives you today's numbers plus the past 14 days. So you can scroll through the last 15 days and it will show you the date and time. It will show you the number of cycles, the open and close time, the vent time, the volume, cycle type counts. So how many non-arrivals, how many fast trips, how many low batteries. So it'll give you a summary of how many events you're having for a given day. You can also set the day start time. So it's going to cut off every day. It's set up to be 8 a.m. But you can change that if your gas day is different. Then the total log, it's the same as the daily log, but this is an all-time cumulative stats. So it's going to give you all the exact same information, but all time, how much open time, how much close time, all the different types of cycles. And then either of these logs can be reset if you want to clear them. If they aren't reset, the daily log, the oldest day will roll off and the new day will be added. The total will just go forever. The last log we have is a plunger stats. So a plunger log that gives you the distance traveled. So as I mentioned before, what we do is every time the plunger arrives, we assume that the plunger went to the bottom and came back up. So we add 2 times the well depth to the total plunger travel. And you can use this to gauge what the plunger wear is without having to take the plunger out of the hole. Then as well, we count the number of arrivals. So if people are using arrivals to determine when to switch out plungers or manage their springs, you can see the total number of arrival events. And once again, this log can be cleared when you change the plunger is probably the best time to clear the log. So that's pretty much our overview. I mean, there's lots more to go over. What I do want to do is point you at our support center. So support.etcorp.ca. You can ask a question. So ask a question about a feature, ask a question about a problem. We're building up more and more resources all the time, but we're trying to put useful information in here so that you don't have to go back to the manual all the time, or maybe there's some special things that weren't captured in the manual that we've put in here. You can access training programs by clicking training. So this training course, as well as others, can be found there. We've got product resources. So if you click on products, we've got all the documentation, tools, accessories, replacement parts by product. So you can find out more information about some of the things you can add on to your controller, and all of the app notes, simulators, programming software are available there. For submitting RMA, so if anybody needs to submit a repair, submit a support ticket. So if you don't find what you're looking for, feel free to submit a support ticket here. That's the fastest way to get support. That goes right into an inbox that's monitored daily during business hours. And then, I'll just show you here the support center. It is interactive, and you can click on the link in this PDF of this presentation. It will take you there. And you can see, it's exactly, what I went over. Things are organized here by use case. So whether you're looking for maintenance, troubleshooting, operation, installation, or integration, but as well, we've also organized it by products, features, accessories, replacement parts, and tools. So we've tried to organize these articles the way that, that you would hopefully use them. Just a little bit about ETC before I let you go. We've been working in this industry in low power, wide temperature range, hazardous controls and sensors since 2001. We have over 12,000 controllers out in the field and 60,000 sensors. Our mission is to democratize industrial automation. There's a little bit about our core values. We really try to be honest. We try to create value and be innovative. We want to work with you, and we want to empower our employees to help our customers and resellers. So if you do want to learn more about ET Corp, you can go to etcorp.ca/about us, or even just etcorp.ca. You can find all of the resources there.